All right, friends, here we go. The next installment of the special topics to get you ready for success on the upcoming AP Calculus exam. Now, if you are a student at Yes Prep Southwest and it is the spring of 2018 when you're watching this video, the secret word is sassafras. If you can remember this word, if you can remember to tell me at the start of class, the normal check that you get for completing the homework becomes a check plus. The secret word is sassafras. Do not tell anyone. All right, so here we are. We're looking at integration. Integration, this is one of those skills that you cannot truly say you're in a calculus class unless you've studied integration, you've practiced integration, you've probably struggled with integration as well. There are some basic ones like the power rule. And the power rule says if I have x to a power that you add 1 to the power and then you divide by the new power plus a constant. And this works as long as the n value is not equal to -1. And there's some examples here. You need to know that the integral of sine of x is negative cosine of x plus c, that constant of integration. That the integral of cosine of x is sine of x plus c. The integral of e to the x is e to the x plus c. Now we start getting into some of the specialty ones. The integral of secant squared of x with respect to x is tangent of x plus c. We've got, I like to think of these as the chain rule version. The integral of sine of kx, if k is a constant, maybe k is 3 or it's 5 or it's pi. The integral is -1 over k, cosine of kx plus c. If you're not sure why we're dividing by k, think about what happens when you take the derivative. If you take the derivative, you multiply by the derivative of the inside, which is k. That'll multiply with the 1 over k to give you 1. That gets you back over here. Anyway, there's a whole lot of integration formulas that you need to know, and I cannot encourage you enough. Memorize them, make flashcards, quiz yourself from time to time. You never know when questions like this are going to show up on a test, on the AP exam, and if you have these committed to memory, it's going to make life so much better. The rest of this video is going to be my working through not necessarily one long free response question, but a bunch of practice questions. What you might want to do is actually try these problems on your own and then compare your work to mine. Choice is yours. Let's get going. Okay, so this first page, these should be relatively quick. Some are going to be a little bit tricky. Let's see what we can do. Okay, n is not equal to 1. What's the integral of x to a power? Well, that's your power rule. And the power rule says add 1 to the power, divide by the new power, and then of course plus c for Charlie, our constant of integration. The integral of 1 over x is the natural log of the absolute value of x plus c. We've talked about this before. It's because of the domain restrictions that come with the natural log of x that we need to have the absolute value bars here. Okay. Number 3, the integral of t to the 5th plus 4t squared minus the square root of t plus the square root of 11. It's the square root of t and square root of 11 that if you're not thinking about them correctly, you're probably going to make a mistake here. So I'm going to rewrite this as t to the 5th plus 4t squared minus t to the half. I'm going to keep the square root of 11 as the square root of 11, and we'll talk about that in just a second. Now, one of the properties of the integral is you can distribute the integral over each of these terms. The integral of t to the 5th is going to be add 1 to the power, divide by the new power, plus the integral of 4t squared, add 1 to the power, divide by the new power, minus integral of t to the half, add 1 to the power, divide by the new power. 1 divided by 3/2 is the same as multiplying by 2/3. Now the square root of 11 is a constant, not a variable. What's the integral of the square root of 11? It's just going to be the square root of 11 times t, because t is my variable of integration, plus Charlie. Okay, let's keep going. The integral of square root of x plus 1 over the 4th root of x. One recommendation I have is to rewrite using your algebra skills. Square root of x is the same as x to the 1/2. 1 over the 4th root of x is the same as x to the negative 1/4 power. I have x to a power, x to a power. Power rule says add 1 to the power, divide by the new power. Plus power rule over here, add 1 to the power, negative 1/4 plus 1 is 3/4, divide by that new power. Okay? Now we get to number 5. And number 5 can be especially tricky. We've got x times the square root of x. There are no properties that we are going to use in a calculus AB class when it comes to multiplication in the integrand. You cannot integrate them separately, although some people are going to try to do that. What you need to do is try rewriting. How about x times the square root of x? Well, isn't that the same as the integral of x times x to the half? When you're multiplying, what happens when the bases are the same? You can add the exponents. So what are the exponents? This is x to the 1st power times x to the half. That becomes x to the 3/2 power. To integrate x to the 3/2 power, you're going to add 1 to the power and then divide by the new power. 1 divided by 5/2 is 2/5. So you get 2/5 x to the 5/2 plus c. If the College Board is being a little tricky, they might try to hide this answer from you. X to the 5/2 means the square root of x to the 5th and then plus Charlie. All right, let's keep going. The integral of cosine 3 theta is going to be 1/3 the sine of 3 theta plus the integral of 3 cosine theta is 3 times sine theta plus Charlie. Okay. The integral of 1 over 2t plus 3, well, if you go back to the notes on the front, the integral of 1 over ax plus b, you're integrating with respect to x, and this is linear, degree 1. You're going to get a natural log, but you've got to be careful here. This is going to be the natural log of 2t plus 3 times 1/2 plus Charlie. In this case, a is 2, b is 3, and the general form says the integral of 1 over ax plus b is 1 over a, natural log the absolute value of ax plus b plus Charlie. Okay? The integral of sine pi t over 4, well, I'm going to rewrite this. Sine of pi over 4 times t dt. And this pi over 4 is a constant. It's a constant, k is pi over 4. If you check back on the front, the integral of sine kx, or in this case sine kt, is going to be negative 1 over k times the cosine of k times t plus c. Now, on the free response part of the exam, this answer is great. Multiple choice, they're probably going to hide this from you. They're going to say 1 divided by pi over 4. Well, that's really 4 over pi. Cosine pi over 4t plus Charlie. Okay, 2 more of what I would think are just basic skills questions. The integral of x squared minus 2x divided by x. Well, just like number 5 was a little tricky because of multiplication, and I always tell my calculus students multiplication is bad news, so is division. Division is always going to require you to do a little bit of creative thinking here. So for example, what if I wrote this as x squared divided by x minus 2x divided by x? First of all, convince yourself that it's legal. I went from one fraction where there was a denominator of x to now 2 separate fractions with the denominator of x. Why would I do that? Well, now I can simplify. X squared over x is x. 2x divided by x is 2. And now I'm going to integrate everything. 1/2 x squared minus 2x plus Charlie. All right, last one. This one I want you to put a star next to in your notes. This is something that the College Board has been sneaking into the exams lately. X squared minus 2x over x plus 1, or divided by x plus 1. What you're going to have to do here is long division, or maybe you call it synthetic division. Maybe you do the box for division. I know for the kids at Southwest, we've been doing the box. How does that work? Here's x plus 1. I'm going to come up with a box that has an area of x squared minus 2x. I'm going to start by putting an x squared over here. If this little box has an area of x squared, has a height of x, the width must be x. X times plus 1 is positive x. But I'm supposed to have an area of x squared minus 2x. Right now I have x squared plus x. To get x squared minus 2x, it must be that there's a negative 3x here. If this little box has an area of negative 3x and the height is x, it must mean that the width is negative 3. And now negative 3 times positive 1 is negative 3. This box has an area of x squared minus 2x minus 3. Now that's a bummer. I'm going to have to add in plus 3 to make everything balance out, but I can't say x times something is going to be 3 unless I want to go with a rational. What this means is when you do the division, you get x minus 3 plus a remainder of 3 being divided by x plus 1. Really what we just did here was some fancy algebra 2. Now let's integrate term by term. The integral of x is 1/2 x squared minus the integral of 3 is 3x plus the integral of 3 divided by x plus 1. That's going to be 3 times natural log of the absolute value of x plus 1 plus Charlie. Definitely come back to number 10. This is just one of those tricky questions. You might expect to see one like this on your AP exam. Maybe it'll show up in some of the progress monitors. It's a matter of doing some fancy algebra to get to something you can integrate and then applying your basic integration rules. Okay, let's keep going. On page 47 in the handout, there is a summary of the technique called integration by substitution. And although everything is sort of spelled out here, let me go through and work through this one problem. I'm going to do 2 problems involving integration by substitution, and then I think I'm going to stop there so that we can use the rest of these questions in class for some practice. Okay, so I'm going to cover this up and just explain step by step what's going on. Get the integral of x over the square root of x squared minus 1 dx. Now, with integration by substitution, this is a technique that you're going to use when you're looking at some tricky integration problems. I like to tell my students the messier the integrand is, the more complicated this is, the more likely it is that integration by substitution is what you're going to need. With integration by substitution, what we're trying to do is undo the chain rule. So we look for the baby, this is the u, and the baby likes to hide in the denominator. So I look in the denominator. The baby likes to hide underneath a radical sign. The baby likes to hide if it's like e to a power, that might be a place. If you're integrating natural log of stuff, that could be a place that you find the baby. If you're integrating sine or cosine or tangent of something, this could be the baby. So in this case, I'm going to say let the baby be x squared minus 1. From here, you take the derivative of the baby, you find du dx in this case, and du dx is 2x. Depending on your calculus teacher and how they taught this to you, you might approach this next bit in a couple of different ways. The technique I showed my kids this year was to solve for dx, meaning take this equation and get dx by itself on one side. Because the dx is in the denominator, we're going to multiply both sides by dx. That means that du is 2x dx. If I divide at both sides by 2x, the 2x's cancel, and we get that dx is du over 2x. Okay? Now, here's the thing. If you've selected the right baby and you found the derivative correctly, when you do this next part, when you actually do the substitution, here's what's going to happen. You've got x over, rather than square root of x squared minus 1, I'm going to write that as square root of u. Rather than dx, I'm going to write du over 2x. And you might say, well, this isn't any better than where we started, but look at what's going to happen. You have an x in the numerator, you're multiplying with a fraction that has 2x in the denominator. I can cancel out my common factors, and what I'm going to be left with is 1 in the numerator and a 2 in the denominator, which means I now have 1 over the square root of u times du over 2. That 2 is in the denominator, that means division. I can factor that out because it's a constant. And I'm trying to integrate 1/2 1 over the square root of u du. Everything is in terms of u. That's the sign that I've done this correctly. Everything is in terms of u. We're not done, but what we should have at this point is something that's much easier to work with than where we were before. Well, let's see. 1/2, 1 over the square root of u is the same as u to the negative 1/2. Now I know it's u, but what happens, the power rule says add 1 to the power, divide by the new power. So I add 1 to the power. 1 divided by 1/2 is 2. Don't forget the 1/2 that you're multiplying by, plus Charlie. 1/2 times 2, that's going to be 1. You get u to the 1/2 plus Charlie, which is the square root of u. Now, you might be tempted to say, okay, we're done. Well, you're not done yet. You started off with an indefinite integral in terms of x. You're going to end your life with a function in terms of x. To do that, we're going to replace u with x squared minus 1. And now you've got the square root of x squared minus 1 plus c. This is the antiderivative. That's your final answer. Now let's do a quick little check step here. If this really is the answer, let's see, I started with this function over here and I said find the antiderivative. My claim is that it's the square root of x squared minus 1. What I'm going to do to check is I'm going to find the derivative of the square root of x squared minus 1 plus Charlie. Well, the derivative of the square root of stuff is 1 over 2 times the square root of the stuff. Chain rule says times the derivative plus the derivative of c, which is 0. I've got a 2 in the denominator being multiplied with a 2x. I have a common factor. And you get x over the square root of x squared minus 1. This is exactly where we started. So I know that I've done this correctly. I've integrated correctly. Nice job. Okay. We've got one last problem that we're going to do, and that's here on the bottom of page 47. And let me get myself some more room to write. Sorry, y'all. Hey there, friends. So I realized the other day that when I was working through the integration by substitution problem at the bottom of page 47 that I made a mistake. And so I want to go back and fix this, so hopefully you won't even know about the mistake because I get rid of this before you watch the video. Okay, so I'm on the bottom of page 47 on special topic integration techniques, and we are going to work through this definite integral. So I'm trying to integrate from 0 to pi over 4.
the sine of 2x divided by 3 cosine 2x plus 4, integrating that with respect to x. Now, we've talked about this before in class. When it comes to integration, the more stuff you have in the integrand, the more likely it is that integration by substitution is the way for you to go. Now, when you're doing u substitution, you look for u, which is, I like to call this the baby, right? So u is the baby. And some places that we look for the baby like in the denominator of a fraction. We look for the baby as the in the exponent of an exponential. Or maybe it's the argument of a log. Or you've got some trig function. You're taking the sine or cosine of something. The baby often likes to hide inside parentheses. The baby also likes to hide underneath the radical sign. These are all common places to find the baby, the u. So let's see what happens here. Given all this information, I'm going to let u equal 3 times the cosine of 2x plus 4. Now, maybe that's the right choice. Maybe it's not the right choice. It's hard to tell in the beginning unless you've done a lot of these. It's this next step when you find the derivative with respect to x. Well, the derivative of 3 times cosine will be 3 times negative sine of 2x times 2 because of the chain rule. So you get that du dx is equal to negative 6 times the sine of 2x. How I know that I selected the right baby is that in the rewrite process, I'm going to be able to replace everything in the denominator with u. And I've got this sine of 2x in the numerator. The derivative of the baby is negative 6 times the sine of 2x. Being off by a constant that you're multiplying by is easily handled. So let's keep going. What we would normally do in integration by substitution is solve for dx. So I'm going to solve for dx. I'm going to do that by multiplying both sides by dx because you guys know I'm a fraction killer. Du is negative 6 sine of 2x times dx. And if I divide, I'm going to get that dx is du divided by negative 6 sine of 2x. Pretty standard. This is what we did earlier. Okay, what you need to do now is rewrite your original integral in terms of u. So let's see, we have sine of 2x. I'm going to leave that alone right now. In the denominator, 3 cosine of 2x plus 4. Well, that's what u is. Dx is du divided by negative 6 sine of 2x. And this is why I'm not bothered if I'm off by a constant that I'm multiplying by. I have a sine of 2x in the numerator. I have a sine of 2x in the denominator. Those can cancel. And what I have right now is going to be the integral of 1 over u. The negative 6 that's in the denominator, that is the same as dividing by negative 6 or multiplying by negative 1/6. Because that's a constant, I can factor it out in front. And I've got du. Well, now that's great, but here's where we need to be careful. When it comes to integration by substitution of a definite integral, an integral that involves limits, you don't just change the integrand to be in terms of u, you have to change your limits as well. You may notice I didn't write my limits of integration yet. That's because there's some side work that I have to do. We know originally that x is equal to 0 and x is equal to pi over 4. I need to convert those over to their u value equivalents. And the way I'm going to do that, I go back to this u equals 3 cosine of 2x plus 4. If x is equal to 0, then u is 3 times cosine of 2 times 0 plus 4. 2 times 0 is 0. The cosine of 0 is 1. Multiply that by 3 and add 4, you get 7. If x equals pi over 4, then u is 3 times the cosine of 2 times pi over 4 plus 4. 2 times pi over 4 is pi over 2. The cosine of pi over 2 is 0. 3 times 0 is 0, plus 4 you get 4. So what that means now is that my limits, they used to be x equals 0 and x equals pi over 4. Now they are u equals 7 and u equals 4. So my limits are 7 and 4. And I would imagine that for a lot of you watching this video, you don't like the fact that your lower limit is larger than your upper limit, and we can switch those, that's fine. So you're going to do an integral from 4 to 7 of 1 over u du. And I hope you know that when you switch those limits of integration, you introduce another negative into the problem. So rather than multiplying by negative 1/6, we're going to multiply by positive 1/6. Let me scoot this up a little bit. And this is where I made a mistake when I filmed this last time. I've got 1/6 times the integral of 1 over u du. Well, what is the integral of 1 over u? That's the natural log of the absolute value of u. Evaluate from 4 to 7. We plug in 1/6, the natural log of the absolute value of 7, minus 1/6, the natural log of the absolute value of 4. That is a fabulous answer. I would encourage you to stop if you're on the free response, but you might be on the multiple choice. And what are some things that could happen on the multiple choice? Well, on the multiple choice, we know that the 7 is positive, so there's no need to write the absolute value there. 4 is also positive, no need to write the absolute value. You could factor out the 1/6 and write this as the natural log of 7 minus the natural log of 4. There is a property of logs that says a log minus a log is the same thing as the natural log of 7 over 4. You could go a step further. I'm just trying to show you all the different crazy things the College Board could do. They could say that this is the same as the natural log of 7 over 4 to the 1/6 power. Right? We've got that property of logs that says the log of something raised to a power, you can bring the power down in front. That also means that when you have something down in front, a constant, you can bring that up and turn it into an exponent. You could also, and I'll make this the last thing, you could say the natural log of 7/4 to the 1/6 power is the same thing as the natural log of the 6th root of 7 over 4. Right? That's just an algebra 2 property of logs. To raise something to the 1/6 power is the same as to find the 6th root. So, all the things are good. Where's a safe stop? Your first safe stop, meaning if this was the free response, where can you stop doing the work? Right here is your safe stop. On the free response, anything you do after this point, you run the risk of losing a point. However, on the multiple choice, that's where the College Board tends to push the algebraic thinking and all those other properties, and you'd have to simplify as much as you can. All right, well, that is it, and I hope you found this helpful. Talk to you soon.